All right, welcome to Chapter 7, Video 3. In this video, we're going to do some more array practice with partially filled static arrays. And we are going to do calculating and items in an array and sorting an array. So let's bring up the notes here. We did partially filled arrays, searching an array, and the next thing is sorting an array. But before we do that, let's bring up the array average code. All right, so we have code here. Array average. Let's take a look at this. This is just some more practice going through an array. So if we take a look at our function prototypes here, this code is called array average. We have the fill array, which is the same as the program searching an array, where we ask the user inside the function how many elements. Again, keep in mind we are sticking with partially filled arrays, and these are static arrays. So we're making arrays that are larger than what we need. So we ask the user how many they want to fill into the array. Of course, when you're testing programs with arrays, you need to fill your array in order to test. So I've given you this code, which is pretty simple and has the function already there to fill the arrays. Printing the array, if you want to practice printing in a row instead of a column, you can practice that. And if you want to practice assigning values to your array, you can certainly do that as well. So this code is all here on Canvas for you to practice different things and see what happens, and that's what I strongly suggest that you do. The third function in this is calculating the average of all of the elements in the array. So let's take a look at that function. This function is going to return a double, so therefore the function call is in the form of an assignment statement. You could also just see out. You don't by this time, hopefully you know that you can. Another way to do that is to put the function call here. And you will not have a variable that stores the result, but the result will be printed onto the screen. And that's perfectly legal in C++. So this function call is an expression that has a return type of double. So anywhere that you could put anything that is a double, you can put anywhere that you can use a double, you can use this expression. So you can see out a double, you can do math with a double, you can put it in an assignment statement. So keep in mind that the result of this function, because its return type is a double, gives you the opportunity to use it anywhere you could use a double. And I encourage you to practice and try different things and see what happens. So let's take a look at how the average is calculated. It's pretty straightforward. We declare a total and initialize it. If you were going to do multiplication, of course, you would initialize your total to 1. But because we're adding, we're going to initialize it to 0. And we're going to calculate. Now, if count is a negative value, this loop will never go, so it's not going to affect our total. And if it's a negative value, we are checking to make sure that if it is a negative value, if count is 0, it's not going to go either, because I equals 0, I less than 0 is not true. So total will be 0 if it's 0. And if count is negative, we want to return a 0. And if not, then we're going to take our total and divide it by count. So this is count less than or equal to 0, not just negative. Negative 0 or negative. All right, next thing we want to look at is sorting an array. So in your book and in this class, there are two types of sorts. There are selection sort and there is bubble sort. So both of the examples that I have given you sort in ascending order, meaning you put the smaller values in the front and the larger values in the back. But you can, it's possible also to do descending order. That's just the examples that we're using. So let's take a look at the selection sort. So the way the selection sort works is that the selection sort is going to go through and it's going to start at the beginning and go and find the smallest element in the array and then move that small element to the beginning. Then it's going to go through and find the next smallest element in the array and move that next smallest element to the second place. And continue and find the third smallest element and put that one in the third location. And find the fourth smallest element and put that one in the fourth location. And so on until it's gone all the way through the entire array and put them into ascending order. So the nice thing that I've done for you is I have given you the code in which to do it. So what this code does is this is just the sorting. It goes all the way through the array and it needs to find the location of the next smallest element. So it's going to start and it's going to start at the beginning and find the smallest element and it's going to return the location of the smallest element. And then it calls the swap function to swap where you are located in the array. So this is doing exactly what I just showed you. It starts at the beginning, finds the smallest element, and then swaps those two. Then starts at the next location, finds the smallest element, and swaps those two. Then goes to the next location, finds the smallest element, and swaps those two. So it will continue and do that all the way through the entire array. So this code is on Canvas for you to test and read and look at and practice. It's called Chapter 7, Selection Sort. This is an example of a selection sort. The other kind of sort is a bubble sort. The idea of the bubble sort is to start at the beginning. If you wanted to go in ascending order, you start at the beginning and you test two elements at a time and you swap and always move the largest one to the right. So for example, if you had 3, 10, 9, 2, 5, you would test 3 and 10, and if 10 was, and see if which one is bigger is going to go on the right. So there would be no swap because 10 is bigger. But then you go to the next one and you compare 10 and 9, and since 10 is bigger than 9, you're going to swap 10 and 9. Then you go to the next one and you compare 10 and 2, and since 10 is bigger than 2, you're going to swap 10 and 2. And then you will go to 10 and 5, and since 10 is bigger than 5, you will swap 10 and 5. Then you got to start back at the beginning and do the next ones and compare. 3 and 9, you don't swap. But then 9 and 2, yes, you will swap. And then 9 and 5, yes, you will swap. Then go back. So you continue to do that until you have gone through and gone through all of them, and then your array will be in ascending order. The nice thing is that I have given you the bubble sort code right here. So if you go into your code, you can practice and take a look at selection sort and bubble sort. At this time, we're not going to have any assignments in which we have to sort arrays, but it is important to understand how selection sort works and how bubble sort works. The last item is two-dimensional arrays. So two-dimensional arrays are arrays of arrays. I will make a PowerPoint on this because it's much easier to visualize two-dimensional arrays by having drawings of them. And I'm not drawing on this computer. I have to go to the other computer. But anyway, so the way that two-dimensional arrays work is that the first part of the array, you use two square brackets. The first square brackets are the number of rows, and the second square brackets are the number of columns. The number of columns needs to be consistent because the way that the computer works is that each row is made up of columns. So for example, if you had 5 rows and 3 columns, row 0 would have 3 columns. Row 1 would have 3 columns. Row 2 would have 3 columns. So the way the computer would get from one row to another row is it would start at row 0, count 3 columns, and then get to row 1. then count 3 columns, and then get to row 2, and then count 3 columns, or 3 columns meaning 3 integers, since this is an integer array. Declaring an array, you just put the number of rows followed by the number of columns, and then you, in order to traverse through an array, like fill an array or print an array, you need to use nested loops. You need an outer loop for the number of rows, and then you need an inner loop for the number of columns, so that each time you would be at, in this case, you would be at 0, 0, then you would go to 0, 1, then 0, 2. If the number of columns is 3, so this is only going to go from 0, 1, 2. So you would start at 0, 0, then 0, 1, then 0, 2, then 1, 0, 1, 1, then 1, 2, then 2, 0, 2, 1, and 2, 2, up until you get to the number of rows. And that's filling an array. This is where you're going to ask the user how many students they want to enter, and the number of quizzes has to be consistent. So in this case, there would be 3 quizzes per student, but the number of students could change with each execution of the program. And printing the array is the same thing. You have the outer loop for the number of rows, which is the count, however many the user decides that they wanted to enter, and the inner loop, which is the number of columns, which in the case of this, the num quizzes, is 3 quizzes. So your outer loop, you could do 50 students, all with 3 quizzes each, or 20 students, all with 3 quizzes each. So the number of rows can change with each execution of the program, but the number of columns must always be the same. And I will make a visual of this so that you guys can better understand it. So please take some time to go through. There are 1, 2, 3, 4, 5, 6, 7, 8 sample codes for Chapter 7. There's Chapter 7 notes, and there are also Chapter 7 slides by the publisher. And if you have any questions, please do not hesitate to ask.